Hello class, we're on to section 2.2, trigonometric functions with the unit circle approach. So the first thing I want to talk about is the unit circle. And so the unit circle is a circle whose radius is 1 and whose center is at the origin. So that's critical for what we're going to build on for this whole class is this unit circle. And related to that is this theorem that I have here, and the theorem says that for an angle theta in standard position, let P be some point on the terminal side of theta that is also on the circle x squared plus y squared is equal to r squared. Now from this we end up having these 6 ratios. So we see that sine is going to be y over the radius, the y-coordinate over the radius. Cosine will be the x-coordinate over the radius. And tangent is going to be the y-coordinate over the x-coordinate, provided the x-coordinate is not 0. If it is, then we end up undefined. Notice that cosecant here is the reciprocal of sine, and secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. If we can remember these things, this will be important and useful for us as we build on this today. So just remember that so we can get through it. All right. Now, one of the most important things that we're going to talk about is the unit circle, and this is the unit circle, and I already filled it in so that it would be it wouldn't take so much time. You can find this on the internet, or you guys can take a screenshot of this, but you can use this on any exam. I will allow it. Some important things that I wanted to point out is this. So the unit circle, the way it works is it always, here's the vertex, and this is the terminal side. This is, or the initial side, I'm sorry. And then the rotation of the angles go in this direction. So you can see these are degrees, so 0 degrees, 30 degrees, 45 degrees, 60, 90, and then it goes all the way around, and when it comes back, I want to do this in a different color so you guys can see this. When it comes back to 0, it becomes 360 degrees, so that's a full rotation around the unit circle, or around any circle. If I'd gone around it twice, that would have been 720 degrees. That's in degrees. Now in radian is these other angles. So 0, pi over 6, pi over 4, pi over 3. Those are all in radian whenever you see pi. And you see that a full circle is 2 pi. So every full rotation is 2 pi times around a circle. That's critical for you guys to know. So again, take a screenshot of this or go ahead and find a chart on the internet. I will allow you to use it. Something else that's important is in the first quadrant, all of the trigonometric functions are positive. So this is for quadrant 1. In quadrant 2, sine and cosecant are positive. In quadrant 3, it's tangent and cotangent. And in quadrant 4, it's cosine and secant. There's a relationship with sine to y and cosine to x. So that is part of the reason why we get the signs we do. I'll go into greater detail as I do examples for you. That being said, this is going to be very, very useful and very important for you guys to understand. So please look at it, and if you have any questions, please let me know. Okay, let's do an example. So if I have a point that's 1/2 radical 3 over 2 on the unit circle, it's going to look like this. So here's our unit circle, and 1/2 radical 3 over 2 is in quadrant 1, and it actually is right here. So 1/2 radical 3 over 2, and we can see from the unit circle, if you want to see it, I can bring it back. You can see that 1/2 1/2 radical 3 is that point. It's 60 degrees. So the 60 degrees that's formed is from the terminal side, or from the initial side to the terminal side. We're going to get 60 degrees there. And our x-coordinate is going to be 1/2. Our y-coordinate is going to be radical 3 over 2. That's something that's going to be important for this problem. We can see from the point that it's giving us that. So if we look at what I gave you, so sine of 60 degrees for this problem, or sine of pi over 3, we can see that there's pi over 3. That's in radians that we can use. It doesn't matter. It's going to give us the same answer, but it depends on what information you're given, if you're given radians or if you're given degrees. But sine of 60 degrees, remember that sine theta is equal to your y-coordinate over the radius. And so our radius in this problem is, since it's the unit circle, the radius is going to be 1. And so we're going to get our y-coordinate, which is radical 3 over 2 over 1, which will give us radical 3 over 2. For cosine of 60 degrees, remember that cosine theta is x over r. So we're going to get 1/2 over 1, which is going to be 1/2. Tangent theta is y over x. And remember, x cannot be 0 in this case. Let's see if it is. So we're going to get radical 3 over 2 over 1/2, which will simplify to be radical 3 over 2. Oop, I'm sorry, I was wrong. It's simply going to be radical 3. Okay. So again, these are values that you guys should have and memorize, or you can use them in your formula sheet if you want for the exam, but they're going to be imperative to understand to use. Cosecant theta is the reciprocal of sine, so it's the radius over y. So that's going to be cosecant of 60 degrees is going to be 1 over radical 3 over 2, which is the same as multiplying by the reciprocal. So that's going to be 2 over radical 3, but we never leave the denominator with radicals in it. So to rationalize this, just in case you don't remember, I'll show you. It's radical 3 times radical 3. And what that's going to yield is 2 radical 3 over 3. That's the answer for cosecant of 60 degrees. Secant of 60 degrees. Again, we got to remember that secant's the reciprocal of cosine. So then instead of 1/2 over 1, we're going to get 1 over 1/2, which is the same as 1 times 2 over 1, which is 2. And then cotangent of 60 degrees is the reciprocal of tangent. So instead of y over x, it's going to be x over y. So that's going to be the 1/2 over radical 3 over 2, which is going to clean up to be 1 over radical 3. And again, we do not leave radicals in the denominator, so we're going to multiply top and bottom by radical 3. So we're going to get radical 3 over 3. So the values that we get for this, our solutions for sine will be radical 3 over 2. For cosine of 60 degrees, it'll be 1/2. For for tangent of 60 degrees, it'll be radical 3. For cosecant of 60 degrees, it'll be 2 radical 3. For secant of 60 degrees, it will be 2. And for cotangent of 60 degrees, it will be radical 3 over 3. Okay. Let me show you another example. This one using radians instead of degrees. And so again, just have it. So we have it. We're going to get sine of our theta is going to be y over r. That's the formula, so I just want to get in the habit of doing that. Now, if we look at the unit circle, remember, this was a 0 rotation, a pi over 2 rotation, pi, 3 pi over 2, and then when I got back to the origin, it's 2 pi, and then 2 pi plus a half is going to be, this is going to become 5 pi over 2, and then this guy will be 3 pi. So 1 rotation is the inner numbers, 2 rotation is the outer numbers. So it's important that we get that. And in fact, I want to clarify that. 1 rotation here is 2 pi. The second rotation through should be 4 pi. But we want to get to 2 pi, so really what it's doing is it's going 1 full circle and then coming back around. So it's 2 pi when it got to here, and then it went an extra pi to get to the 3 pi. So then if we remember from the unit circle, this point right here is going to be -1 comma 0. And so we're going to get sine of 3 pi is equal to 0 over, since it's a unit circle we're using, 0 over 1. And so our exact answer is 0. Okay? For our next example, we'll use degrees. And so let's see if we can demonstrate that. So again, this would be 0, 90, 180, this is 270, and if we went all the way through, this would become 360 degrees, correct? Now, when we're doing this, we're going 225, so it's between 180 degrees and 270, so the way I'm going to find out where it falls, how many more degrees I need to add, I'm going to go 225 minus 180, and that's going to be 45 degrees. And the reason I'm doing that is because I need to add 45 degrees to get to this point here. So if I looked at the unit circle, I could see that this would be negative radical 2 over 2, comma negative radical 2 over 2. And so cosine, remember, is cosine theta is x over r. Again, our radius here is 1. So cosine of 225 degrees is going to be a negative radical 2 over 2 over our radius 1, which is going to give us a negative radical 2 over 2. All right, there's that one. Let's work out a problem where we're just given some information and we're going to find all our information. So we're going to find all of our solutions for the trigonometric functions. So if we look at 30 degrees or pi over 6, it's going to be this point here. And from the unit circle, we know that that's going to be radical 3 over 2, comma 1/2. So that's our x and our y coordinates. So then, again, remember sine theta is y over r. Our radius is 1. And so sine of, I'll use degrees for this, is going to be our y value is 1/2 and our radius is 1. So we're going to get 1/2 as our solution for sine of 30 degrees. Now to save time, I know that cosecant of 30 degrees is simply the reciprocal of sine of 30 degrees. So if sine is 1/2, cosecant has to be 2. But if you don't see that, it's okay. Just remember it is going to be r over y. Okay. For cosine of theta, we know it's x over r, so cosine of 30 degrees is going to be radical 3 over 2 over our radius of 1, and so we get radical 3 over 2. Secant is the reciprocal, so you can see that's going to be r over x. So secant of 30 degrees is going to be 2 over radical 3. It's just flipping the fraction, but again, we don't like to have radicals, so we're going to multiply by radical 3 top and bottom, and we'll get 2 radical 3 over 3. All right. Tangent theta, remember, is y over x. So then tangent of 30 degrees is going to be 1/2 over radical 3 over 2, which will yield 1 over radical 3. And when we multiply top and bottom by the radicals, we're going to get radical 3 over 3. Okay. Cotangent then is the reciprocal. So what we can say is cotangent of 30 degrees really is 3 over radical 3, the flipping of it. But then we need to rationalize. So we'll get 3 over radical 3 over 3, which yields 3. If you have any questions on these, if you think that I may have done them a little quickly, by all means, please post a question on this YouTube, or you can even post it in class and I'll answer for you guys so that you can better understand this. But this is the fun part of trig, actually. I really enjoy this. Okay. Now we can also do products. So if we look, I know that sine of 45 degrees is radical 2 over 2 by looking at the unit circle, and then cosine of 60 degrees is going to be 1/2. So then all we're doing here really is we're going sine of 45 degrees times cosine of 60 degrees. So we're getting radical 2 over 2 times 1/2, which is going to give us radical 2 over 4. And that's our solution for this problem right there. Okay. This next problem is pretty fun too. So if, for simplicity's sake, so we can do this, we know that pi over 4, if I look at pi over 4, I know that pi over 4 is going to yield the point radical 2 over 2, radical 2 over 2. And I know that pi over 2 is going to give me the point 0, 1. So that's going to be useful for me in this problem. So secant really is the reciprocal of cosine. So since it's the reciprocal of cosine, cosine of pi over 4 would be radical 2 over 2. So then secant of pi over 4 is going to be 2 over radical 2. But again, we know we don't want that, and so we're going to end up with radical 2 as our answer. So we've got that piece, so it's going to be radical 2, but that whole quantity is going to be squared because we have a square there. Plus, now let's find the cosecant. And cosecant, remember, sine of pi over 2 is 1, and cosecant is simply the reciprocal of that. So cosecant of pi over 2 is going to be 1 over 1, which is 1. So we're going to add 1 to this. And so that's going to give us radical 2 squared is going to be 2 plus 1. So the answer here is going to be 3. So this answer is 3. Okay. I hope this has been beneficial. Please watch this video multiple times if need be, but if you'd like additional examples, by all means, let me know, and I'll do that for you. All right. All the best.